Alright guys, so now ang pag-uusapan natin is about overall energy balance for steady-state flow system. So, ang magiging reference natin for this topic is this book, itong Transport Processes and Unit Operations, 3rd edition by Kristie Geankoplis. Okay, so in overall energy balance for steady-state flow system, the common special case of the overall or macroscopic energy balance is that steady-state system with one-dimensional flow across the boundaries, single inlet, single outlet, and negligible variation of heights, density, and enthalpy across either inlet or outlet area. So, meron tayo ditong diagram. Makikita din natin yan dito sa ating book. No? So, ito yung makukuha nating equations if we do the derivation of the overall energy balance. No? So, we already talked about the total energy in our previous video. So, hindi na tayo magdi-discuss pa more about the derivation. Now, if you're really interested to know kung paano na-derive itong equations natin, you can always refer to the book. Okay, but to save time, we are just going to talk about these equations and we are going to solve a problem para makita natin kung paano ina-apply itong ating equation. So basically, halos kapareho lang din siya nung ating total energy na sinosolve in our previous problems. However, dito, meron tayong i-consider na energy that is produced by the heat transfer sa ating system or yung shaft work dulot ng pumps or turbines. So, on this diagram, we have our point 1 kung saan dito ang ating inlet and it is passing through dito sa ating pump or turbine which is our shaft work. And then, it passes also to a heater bago siya lumabas dito sa point 2 which is our discharge. No? So, itong reference plane natin na nakasulat dito, ito yung datum line. Okay, na magiging reference natin for the position, for our potential energy. So, tignan natin itong ating equation. So, we have here, okay, the difference of the enthalpy from the point 2, okay, and point 1. So, we have enthalpy on point 2 minus the enthalpy of point 1. Plus 1 over 2 alpha. Okay? Itong alpha natin dito is what we call the kinetic energy velocity correction factor. Okay? So, we will be discussing that later on. And then, we have here V2 squared minus V1 squared. So, yan ang ating average velocity dito sa point 2 and the average velocity dito sa point 1. Okay? So, as you can see, katulad ng napag-usapan natin last time, this is our kinetic energy, dito sa ating system dito. And then, of course, we have our potential energy, So, we have the energy due to position on point 2 and the energy due to position on point 1. And this is equal to the heat transfer dito sa ating system minus our shaft work. Okay, so now we have here the English unit kung saan ginagamit natin itong ating GC for our acceleration due to gravity. Okay, so kailangan natin tandaan itong mga useful conversions natin when we are dealing with energy. So, gagamitin natin to in order to have consistency sa ating mga units. So, 1 BTU is equal to 778.17 feet pound force, which is also equal to 1055.06 joule or 1.05506 kilojoule. Okay? Then 1 horsepower is equal to 550 feet-pound force per seconds or 0.7457 kilowatts. Now, 1 feet-pound force over pound mass is equal to 2.989 joules per kilogram. And 1 joule is equal to 1 Newton meter or 1 kilogram meter squared per second squared. Okay, so nabanggit natin kanina itong ating alpha na nandito sa equation, which is the kinetic energy velocity correction factor. So we are not going through dito sa derivation. Ang gusto lang nating maipakita dito is what will be the value of alpha if the flow is laminar or if the flow is turbulent. Okay? So, yun lang naman ang kailangan nating makita dito sa ngayon. So, if our flow is laminar, katulad ng nakikita natin dito, if the flow is laminar, our alpha is equal to 0.5, okay, or 1/2. Okay, so, for laminar flow, the value of alpha to use in kinetic energy term for equation 2.7-10 is 0.5. Okay? So, ito yung value ng ating alpha for laminar flow. So, how about if we have turbulent flow? So, in turbulent flow, in most cases, except for precise work, the value of alpha is taken to be 1.0. Okay? So, our alpha for turbulent flow is equal to 1.0, while our alpha for laminar flow is equal to 0.5. Okay? So, yan lang naman ang pagkakaiba niya, no? So, yan ang gagamitin natin dito sa ating kinetic energy. Okay, so, we're going to apply yung natutunan natin for overall energy balance based dito sa transport processes and unit operation by Kristie Geankoplis dito sa problem na to. But this problem is actually a sample problem sa book. Okay, so we're just going to solve it para makita ninyo in detail, no? Kasi there are values there na pinakita na lang but it was not explained kung paano nakuha, no? So we're going to solve this problem para makita natin how are we going to apply yung equation natin kanina dito sa problem natin, ano? So first, let me write yung ating equation. We have our overall energy balance as H2 minus H1, okay, plus 1 over 2 alpha times velocity 2 squared minus velocity 1 squared, okay, our kinetic energy, plus G times C2 minus C1, our potential energy, which is equal to Q minus, okay, our shaft work. Okay, so yan ang gagamitin nating equation dito sa ating problem. Now, let me read the problem para maintindihan natin siya, no? Water enters a boiler at 18.33 degrees Celsius and 139 kilopascal. So, ito yon. Our temperature is 18.3 degrees Celsius and 137.9 kilopascal ang ating pressure, no? At an average velocity of 1.52 meters per second. So, ito yung ating velocity 1, which is 1.52 meters per second, no? So, pumapasok yung ating water dito sa ating system. Okay, so, exit steam at a height of 15.2 meters above the liquid inlet leaves at 137.9 kilopascal and 148.9 degrees Celsius with an outlet velocity of 9.14 meter per second. Okay, katulad ng nakasulat dito, no? So, this is our outlet with velocity of 9.14 meters per second. Our temperature is 148.9 degrees Celsius with a pressure of 137.9 kilopascal. So, ito naman, the difference in height or the location, position between our inlet and outlet stream. Okay? Now, at steady state, how much heat must be added per kilogram mass of steam? The flow in the two pipes is turbulent. Okay, so meron tayong pinapasok, no, or ina-add na heat dito sa ating system. So, yan nga ang ating required. We need to find out how much, okay, heat must be added per kilogram mass of steam. So, how much heat must be added per kilogram, okay? So, solve natin yan using this equation right here. Okay, so we need to take note, okay, that our flow is turbulent. Okay, so therefore, if our flow is turbulent, our alpha is equal to 1.0. Diba? Tulad ng napag-aralan natin kanina. Now, we are only adding heat dito sa ating system. We do not have shaft work tulad ng pumps or turbines. So therefore, our WS here, which is the shaft work, is equal to 0. Okay? So let me rearrange this. So our Q is equal to H2 minus H1, okay, plus 1/2 velocity 2 squared minus velocity 1 squared plus G, then C2 minus C1, okay? So we just cancel itong ating shaft work. Now let us solve this one by one, no? First, let us solve for the kinetic energy, no? Okay, so let us solve our kinetic energy. So unahin natin itong ating velocity 1, okay? So we have velocity 1 squared over 2, okay? Para later on, isusubtract na lang natin. So if you're going to distribute itong ating 1/2 dito sa ating equation, we will have here, okay, V2 squared over 2 minus V1 squared over 2. So, solve na natin itong V1 squared over 2. So, basically, our V1 is equal to 1.52 meters per second. No? So, we will have 1.52 meters per second. We're going to square that and divide that by 2. Okay, so let me solve that. Okay, we have 1.52 squared divided by 2, which is equal to 1.1552 square meter per second squared. No? So we have 1.1552 square meter per second squared. Now, bakit ganito yung ating unit, no? This is actually due to the derivation na ginawa natin dito. But actually, itong unit natin dito is in joules per kilogram. Okay, why it becomes joules per kilogram? So, as I said, we only have these units dahil sa derivation na nangyari, no? Because as you can see, if we have joules per kilogram, pakita natin how do we have that. So we have joules per kilogram. Okay, so 1 joule is equal to 1 Newton meter, no? Tulad ng nabanggit ko kaninang conversion. Now, 1 Newton is equal to 1 kilogram meter per second squared. Okay? So, let us check our dimensions dito, no? Our joules will be cancelled out, our newtons will be cancelled out, and our kilogram will be cancelled out. So, as you can see, ang naiwan sa ating unit dito is meter times meter, which is meter squared, over second squared. Okay? So, we only have square meter by second squared here due to the derivation. But actually, our unit here is joules per kilogram. Okay, so we're going to use that unit dito sa ating mga makukuha sa kinetic energy. So our B1 squared over 2 is equal to 1.1552 joules per kilogram. Okay, so meron na tayong value ng V1 squared. Now, let us get the value of V2 squared over 2. Which is equal to, our V2 is equal to 9.14 meters per second. No? So we have 9.14 meters per second squared over 2. Okay, so we are going to solve that again. Let me clear this. So we have 9.14 squared divided by 2, which is equal to 41.77. No? So we have 41.77, and this is in joules per kilogram. No? So meron na tayong value ng V2 squared over 2. Now, let us get the value of our potential energy. No? So, in our potential energy, we have to get the value of Z1 and Z2. So, tignan uli natin yung ating diagram, no? So, as we can see here, given sa atin yung distance between our first stream and the exit stream, no? Yung enter stream and exit stream, which is yung elevation nila is equal to 15.2 meters. So, that means we can have our inlet stream level as our datum line. Okay, so if our entering stream is our datum line, therefore our Z1 is equal to 0. Okay, so we have this elevation right here. So therefore, at this level, our C2 is equal to 15.2 meters. No? So we have 15.2 meters para sa ating C2. No? So therefore, in here, our C1 is actually equal to 0. No? So we need to multiply our acceleration due to gravity to Z2. So, yan ang kukunin natin. No? So, we have our C1, which is equal to 0, but our C2 is equal to 15.2 meters. But, ang kailangan natin makuha as per our equation is G times C2. Okay, so our C2, which is 15.2 meters, multiplied to the acceleration due to gravity, which is 9.81 meters per second squared. Okay, so our answer here will be, we have 15.2 times 9.81, which is equal to 149.1 meter squared per second squared. So, katulad nung nabanggit natin kanina, this is 149.1 joules per kilogram. Okay? So, meron na tayong value ng C2, no? So, alam na natin yung value nito, alam na rin natin yung value nito. Now, what remains is itong difference ng ating enthalpy. So, kailangan nating makuha yan, ano? So, let me write again our equation dito sa baba para mamaya, kapag nakuha na natin yung value ng ating enthalpy, it will not be difficult to substitute our value. So, our Q is equal to H2 minus H1, okay? Plus, we have V2 squared minus V1 squared over 2, okay? Plus, we have C2 minus C1 times G. Okay? But of course, we already know that our Z1 is equal to 0. No? So, substitute natin mamaya yung ating values dyan. But first, we need to get the value of our enthalpy dito sa ating entry and exit stream. No? Kailangan natin makuha yung H1, which is our enthalpy here sa entry, and H2, which is our enthalpy dito sa exit. Okay? So, tingnan natin yung given natin. Sorry, I need to go back. Our given here is that we have, in our entry stream, we have 18.3 degrees Celsius and 137.9 kilopascal, no? Sa ating point 1. So, start tayo, kunin natin ang ating enthalpy sa point 1. Okay? So, at point 1, we have this given. We have temperature 1, which is equal to 18.3 degrees Celsius, and pressure 1, which is equal to 137.9 kilopascal. So, kung titignan natin itong ating steam table, makikita natin sa Appendix A.2-9 ng same book, no, yung Transport Processes and Unit Operation by Kristie Geankoplis, makikita natin dito that in our temperature, which is 18.3, which is between this, okay, our vapor pressure is just around 2.4, no? Okay, or 2.06, just around that value, no? But, in kilopascal. But our given is way higher. Okay, so therefore, our pressure 1 is actually greater than our vapor pressure. So therefore in here, since our pressure 1 is greater than the vapor pressure, therefore we have here a saturated liquid. Ano? So therefore we are going to get the value of our enthalpy from here. Okay? Okay, so we're going to use that to get the value of our enthalpy. So our temperature is 18.3, no? So it will be between 18 and 21, no? So let me write that dito sa ibaba para mas madali natin siyang ma-visualize, no? So in our temperature in degrees Celsius, we have 18, okay? And we have 21. While ang given natin sa ating point 1, we have temperature of 18.3 degrees Celsius. No? So we have here 18.3 degrees Celsius. Okay, so we need to get our enthalpy, no? Which is in kilojoules per kilogram. So we have kilojoules per kilogram. Okay, so at 18 degrees Celsius, ang enthalpy natin for the liquid is 75.58. So we have here 75.58. And at 21 degrees Celsius, our enthalpy is 88.14. Okay? Now, since we need to get the enthalpy at 18.3, we are going to mark this as H1. Ano? So our H1 will be somewhere here. Okay, so ang gagawin natin dito, we need to interpolate para makuha natin yung value ng H1. Okay, so I'm going to subtract first itong H1 dito sa 75.58, and then I'm going to divide that with the difference between 88.14 and 75.58. And I'm going to do that the same here, no, sa ating temperature. So we can interpolate accordingly. Okay, so let us do that. So we have our H1. So H1 minus 75.58 divided by 88.14 minus 75.58. Okay, and this is equal to 18.3 minus 18 divided by 21 minus 18. Okay, so we did the same dito sa ating enthalpy and here sa our temperature. Now we need to solve for the value of H1. Okay, so hindi na natin siya patatagalin pa, no? We're going to solve that directly dito sa ating calculator, no? So we have first 18.3 minus 18, ano? So we have 18.3 minus 18, which is equal to 0.3 divided by ito, 21 minus 18, 21 minus 18. Then we're going to multiply that dito sa 88.14 minus 75.58. Okay, because we're going to transpose that to the right side of the equation. So we're going to multiply that here, 88.14 minus 75.58 is equal to 1.256. So we have 1.256. Then we're going to transpose this 75.58 here. So we have plus 75.58. So our H1 is therefore equal to, okay, plus 75.58. So our H1 is equal to 76.84. 76.84. And our unit here is in kilojoules per kilogram, no? Okay, so we have now the value of H1. So, let me write that here para mas madali natin ma-visualize, no? So, our enthalpy so our H1 is equal to 76.84 kilojoule per kilogram. Okay, so kunin naman natin yung H2 natin. So, yung ating enthalpy dito sa ating exit stream. So, given din ang ating temperature at pressure. So, our temperature is 148.9 degrees Celsius and our pressure is 137.9 kilopascal. So, we're going to use, again, a steam table dito sa Appendix 2, 8.2-10. Now, why we are going to use this? This is for superheated steam. Okay? Because in our point 2, at point 2, we have our temperature 2, which is equal to 148.9 degrees Celsius, and our pressure 2, which is equal to 137.9 kilopascal. Okay? Now, if we are going to check our steam table for saturated liquid, or saturated water, you will see that in this temperature, makikita mo doon that in our temperature in degrees Celsius, we have 140 degrees Celsius and 145 degrees Celsius. And our vapor pressure, in kilopascal, in 140 degrees Celsius, we have 316 kilopascal. And in 145 degrees Celsius, we have 415 kilopascal. So, as you can see dito, at 148 degrees Celsius, our pressure is 137.9 kilopascal only. Samantalang ang vapor pressure is 316 kilopascal. Therefore, our P2 is actually less than our vapor pressure. So, in that case, it tells us that on this given pressure na mababa, mataas ang ating temperature. Therefore, we have here superheated steam. That is why we are going to use the superheated steam table. Okay, so how are we going to use this? Okay, so kailangan maintindihan natin kung paano natin to gagamitin. So let me be clear about this one. Our given temperature here is 148.9 degrees Celsius and our pressure is 137.9 kilopascal. So, dito sa left side natin, given yung absolute pressure natin in kilopascal. So, our pressure is 137.9. So, it will be between here. Okay, so we will have here 137.9. And for the temperature naman, we have 148.9 degrees Celsius, which means it is between here, 100 and 150. Okay? So that means our enthalpy that we will be considering should be somewhere here. Okay? In between here. So, para mas madali natin siyang ma-visualize, let me write that dito sa ibaba. So, we have here 75 kilopascal. So, our pressure in kilopascal, we have 75 kilopascal. And then, yung next na given is 100 kilopascal. Okay? Samantalang ang kailangan natin makuha is yung nandito sa pressure na 137.9 kilopascal. So, I'm going to write that here. 137.9 kilopascal. Okay? And then we're going to get the enthalpy, which is this one. Okay? Our enthalpy in 75 and 100. So, in 75 kilopascal, at 100 degrees Celsius, our enthalpy is, our enthalpy here is 2679.4. So 2679.4. Okay, so this is at 100 degrees Celsius, no? And of course, ang kinukuha natin dito is yung enthalpy. Okay, sa 100 kilopascal naman, our enthalpy is 2672.2. Okay? And of course, ang unit ng ating enthalpy here is in kilojoule per kilogram, no? So we have kilojoule per kilogram. Okay, so next is yung 150 degrees Celsius. So let me write that here. We have 150 degrees Celsius. So ito yon, 150 degrees Celsius. So ito naman ang kukunin natin. At 75 kilopascal na pressure natin, we have 2,778. 2,778.2. Okay, and then in 100 kilopascal, we have 2,776.4. Okay, so we have 2,778.4. Okay, so ang hinahanap natin is the enthalpy, which is in here, no? In pressure of 137.9. But it is on this temperature, which is 148.9 degrees Celsius. So nasa pagitan nilang dalawa, no? So therefore, ito ang ating enthalpy at 100 degrees Celsius. Okay? If you're going to extrapolate this, ang makukuha natin is yung enthalpy at 100 degrees Celsius. And then ito naman, kapag in-extrapolate natin, ang makukuha natin is yung enthalpy at 150 degrees Celsius. Okay, so ang gusto nating makuha is yung enthalpy in 148.9. So that is what is going to be our H2, no? So yan ang kailangan nating makuha. Ang pressure is nasa 137.9 at ang temperature is 148.9. So first, extrapolate natin ito para makuha natin itong ating enthalpy in 100 degrees Celsius. So how are we going to do that, no? First, I'm going to subtract itong ating enthalpy dito sa unang given natin, yung enthalpy in 75 kilopascal, and then I'm going to divide that to the difference of this one, enthalpy in 100 kilopascal, and the enthalpy in 100 degrees Celsius. So we're going to do the same here. We will subtract that here divided by the difference of that here, no? So gawin na natin yan. Let us solve for H100, no? So our H100, our enthalpy at 100 degrees Celsius, okay, minus 2,679.4 divided by 2,672.2 minus 2,679.4. And this is equal to, ito na sa ating pressure, we have 137.9 minus 75 divided by 100 minus 75. Okay, so katulad ng ginawa natin kanina, no? So hindi ko na siya pahabain pa. We're going to solve this sa ating calculator, no? So our H100 is equal to, let me solve this. So unahin natin to. We have 137.9 minus 75. Okay, equal to, then divided by 100 minus 75. Then, we're going to multiply that dito sa denominator natin because we're going to transpose that papunta sa right side ng ating equation. So, we're going to multiply that with 2,672.2 minus 2,679.4. Okay? So, this is equal to negative 18.1152. But as you can see, we have minus 2,679.4 here. So, we need to transpose that dito sa right side ng ating equation. Therefore, I need to add 2,679.4. So, we will have 2,661.3, no? So, our H100 is equal to 2,661.3 kilojoules per kilogram. Okay, so may value na tayo ng H100, no? So, now we need to get the value nitong H150, no? So, ganun din ang gagawin natin, guys. Now, we're going to subtract this here and this one here. Then, still, we're going to use our pressure right there, no? So, our H2 or our H150 degrees Celsius, okay, minus 2,778.2 divided by 2,778.4. So, 2,778.4 minus 2,778.2. Oh, I'm sorry, we have a wrong value here, no? So, our 150 degrees Celsius, this is 2,778.2. So, this is 2,776, no? So, this is 2,776.4. So, I need to change this. Mali yung value natin. So, this is 2,776.4, no? So, that is what we need to use here. Okay? So, let me remove this as well. We wrote a wrong value kasi earlier, no? So, we have 2,776.4 minus 2,778.2. Okay, so this is equal to 137.9 minus 75 over 100 minus 75. So now we can solve for H 150 degrees Celsius. Okay, so let me solve this again. So we have 137.9 minus 75. Sorry. Minus 75. Oh, again. Minus 75. Divided by 100 minus 75. So, we're going to multiply that here because we're going to transpose that sa right side ng ating equation. So, we have 2,776.4 minus 2,778.2. We have negative 4.5288. But we have 2,778.2 here. We're going to transpose that sa right side ng ating equation. So, we're going to add that. So, plus 2,778.2, which is equal to 2,773.67. No? So, our H 150 degrees Celsius is equal to 2,773.67 kilojoule per kilogram. So, hindi pa natin nakukuha yung gusto nating makuha, which is H2, no? But, we already know the value of H100 and H150. So let me write that again. No? So our temperature is 100, 148.9, and 150. No? So we have our temperature, which is 100, 148.9 degrees Celsius, and 150 degrees Celsius. So our H100 is equal to 2661.3. No? So we have 2661.3, and our H150 is 2773.67. So here we have our H2. Ito yung gusto nating makuha. Now we're going to interpolate para makuha natin yung H2. So again, lalagyan ko ng pattern para madali natin siyang masundan. Ano? So our H2 will be subtracted here. And then we're going to subtract this one here. And we're going to do the same dito sa temperature. We're going to subtract here. And we're going to subtract this here. Okay, so now we're going to do our interpolation. So our H2 minus 2661.3 over 2773.67 minus 2661.3, and this is equal to 148.9 minus 100 divided by 150 minus 100. Okay, so now we can get the value of H2. Okay, so calculator ulit tayo. Starting with this, no? So we have 148.9 minus 100 divided by 150 minus 100 times itong denominator natin because we're going to transpose that dito sa right side. So we have 2773.67 minus 2661.3. 2661.3. Okay, so we have 109.89786, but we have here minus 2661.3. Transposing that to the right side, we're going to add that here. So plus 2661.3. So we have 2771.2. So we have 2771.2 kilojoules per kilogram. So meron na tayong value ng H2. Now we're going to write that in here. Okay, so meron na tayong value ng H2, which is equal to 2771.2 kilojoule per kilogram. Okay, so dito sa ating formula, we need to get the difference of H2 minus H1. No? So, sinulat natin yan dito. So, our H2 minus H1, let me write that here, is equal to 2771.2 minus 76.84. Diba? So, subtract lang natin yung H2 sa H1. So, let me solve that in our calculator. We have 2771.2 minus 76.84. So, we have 2694.4. Right? So, this is 2694.4. But our unit here is kilojoule per kilogram. Okay? Tulad ng nakasulat dito. But as you can see, lahat ng na-compute natin in kinetic energy, potential energy is all in joules per kilogram. So let us convert this to joules per kilogram. So we're going to multiply this to 1 kilojoule. Okay, I'm sorry, we're going to 1 kilojoule or 1000 joule. Okay, so this is equal to, okay, so we will have a large number here. So we have 2.694 times 10 to the 6 joule per kilogram. Okay, so meron na tayong difference ng H2 minus H1. So now let us substitute our values here. So our Q is equal to H2 minus H1, which is 2.694 times 10 to the 6. So we have 2.694 times 10 to the 6. So ang unit na natin dito is joule per kilogram, no? So plus V2 squared over 2, which is equal to, this is our 72 squared over 2, which is 41.77, minus our V1 squared over 2, which is 1.1552, no? So, our V2 squared over 2 is equal to 41.77, minus our V1 squared over 2, which is 1.1552. So, we have 1.1552 plus our C2G. Ito na yung value natin. C2G is equal to 149.1. So, 149.1. Okay, so ang unit natin dito, don't forget, is joule per kilogram. Okay, so now, we can solve. So, lagyan na rin natin ito para hindi tayo malito, no? So, now we can solve for our Q. So, let me use again our calculator. So, nandito pa yung kaninang sinolve natin, yung value ng ating H2 minus H1, no? So, now we're going to add that here sa ating kinetic energy, no? So, we have 41.77 minus 1.1552. Then, we're going to add 149.1. So, we have 2.6945 or 46. So, we have 2.6946 times 10 to the 6 joules per kilogram. So, converting that to kilojoules, so 1000 joules in 1 kilojoule. So, our Q is equal to 2,694.55 kilojoules per kilogram. So, this is our answer to this problem, no?